Yeah, good morning, students. It's my pleasure to introduce this another important application of the stack. That is a third application, which we can call it as the Tower of Hanoi problem. Now, I would like to share my screen. So, hope my screen is visible to you. So, this is the CDT 15, week 5, lecture 3, Tower of Hanoi. So, this is the third important application of stacks. So in this particular CDT, we would like to discuss about how do we solve this problem of Tower of Hanoi puzzle. We will discuss that. So summary of the previous CDT is that in the previous classroom discussion topic, we had a discussion on recursion and another important application of stack is Fibonacci series, how this Fibonacci series is printed using this recursion. So this is the recursive definition of the nth Fibonacci number. To print the series, we have called used this function in a for loop. Whenever we are writing any recursive function, so implicitly the system stack is used to store the call stack trace. So that is the reason we are saying that the applications of the stack or the recursive functions like factorial and GCD and then Fibonacci series problem and then Tower of Hanoi. All these are the problems which can be solved using recursion. So if you are using recursion, in turn it is making use of the system stack. So the Fibonacci series time complexity, we had seen that it is order of 2 power n and the space complexity is order of n. Now the today's topic for discussion is applications of stacks. We are discussing about the third important problem, that is the Tower of Hanoi problem. So the lecture objectives is that this session will develop the students' knowledge on applications of the stack, that is the Towers of Hanoi problem. So the lecture outcome is that after completion of the session, students will be able to develop the code using recursion for solving of these Towers of Hanoi problem. So what is this Towers of Hanoi problem is basically? So Tower of Hanoi is a mathematical puzzle where we have three rods and the n number of disks are there. So the objective of the puzzle is to move the entire stack of disks from one rod to the another rod by following these simple rules. The first rule is that we can move one disk at a time. Each move consisting of taking the upper disk from one of the stacks and placing it on top of another stack. That is, a disk can only be moved if it is the uppermost disk on the stack. So no disk may be placed on top of a smaller disk. So these disks are rings or of different sizes and stacked upon in ascending size order. That is, the smaller one sits over the larger one. So there are other variations of the puzzle where the number of disks increase, but the tower count remains the same. That is, we have these three towers only, or three pegs or rods, we can say it as only we have, and we have to solve this particular puzzle. So here we are given an example in this particular diagram. So these are the towers we have, or we can say it as this is the spindle or a peg, we can call it as. So tower 1, tower 2, tower 3. Here we have three towers are there, and these are the disks we have here. For example, three disks are there. So this is the smallest disk and this is the largest disk. So in this order only we have to move from this source. You can take it as this is a source tower, and this is the auxiliary tower, we can call it as auxiliary tower we can use, and this is what the destination tower. So we have to exactly move all these disks by making use of this auxiliary tower, and all the disks has to be moved on to the destination tower. So if we have this tower of Hanoi is having n number of disks here, So total number of moves that are required here is that to solve this particular problem, 2 power n minus 1 steps are required to solve this particular problem. So in this particular figure, we have shown that there are 3 disks we have. So 2 power 3 minus 1, which is equal to 7 steps. 7 steps are required here to exactly transfer all the disks from the source to the destination, exactly in the same order. Fine. So what is this algorithm? How we can write the algorithm for solving of this problem? So to write an algorithm for Tower of Hanoi, so first we need to learn how to solve this problem with lesser amount of disks. Say if we have one disk or two we have. So we are taking this here source, destination and auxiliary towers we are taking here. If we have only one disk, then it can be moved from source to destination peg directly. So we divide the stack of disks into two parts. The largest disk, that is the nth disk, is in one part, and the remaining n minus 1 disks are in the second part. So our aim is to move the disk n from the source to the destination and then put all other n minus 1 disks on top of it. So we can imagine to apply the same in a recursive way for all given set of disks. So these are the 3 important steps that are required to solve this Tower of Hanoi problem having n number of disks. In the first step, what we have to do here is that we have to move n minus 1 disks from source to auxiliary peg or auxiliary tower. We have to move that. And then the second step is that move nth disk from the source to the destination. And in the third step, move n minus 1 remaining disks from the auxiliary to destination. So these are the 3 steps which are required to solve this particular problem. Now this is a recursive algorithm we are writing here. So algorithm name is Hanoi we are putting here. That is the procedure. Here this algorithm is taking 4 parameters. N is the number of disks and this is the source tower and destination tower, and this is auxiliary tower. 3 towers we are giving. The name of the towers also we can give it as A, B, C. Like that you can give. Okay, or tower 1, tower 2, and here source, destination and auxiliary. So if n is equal to 1, then move the nth disk from source to destination. Else, if n is greater than 1, then we have to call this Hanoi of, recursively we are calling this Hanoi of n minus 1 disk from source to auxiliary and then auxiliary to destination. Then move nth disk from source to destination. Then recursively we have to call, this is the third step, Hanoi of n minus 1 disks from auxiliary to destination by taking the source as auxiliary tower. This is the procedure or algorithm, recursive algorithm for solving of this towers of Hanoi problem. Now we are going to write the code in C language to solve this particular problem. So we are writing that function tower of Hanoi. So int n, that is the number of disks. So char from rod. So this is the source. Char to rod, this is the destination, and char auxiliary rod, this is the name for the auxiliary tower. So we are taking only single character naming for towers. Okay, and then if n is equal to 0, then simply we are returning that. Otherwise tower of Hanoi of n minus 1 from rod to auxiliary to rod, and print move disk percentage d from rod percentage c to rod percentage c, n comma from rod comma to rod, then tower of Hanoi of n minus 1 comma auxiliary rod to rod comma from rod we are source we are taking it as an auxiliary here. This is what the recursive function. Here you can take it as n is equal to 1, also you can take it as a terminating condition. So here in this main function I am calling this number of disks as 4, n is equal to 4, and then I am calling tower of Hanoi of n comma a comma c comma b. So a to c we want to move, b as an auxiliary. rod or tower we have to use. So this is what the function code for solving this particular problem. And then this is a reflection spot. So what is the output of this following code? So that we can compute that. It is a recursive code. So solve this particular code. So LOs are revisited here. After completion of this session, students will be able to develop the code using recursion for solving of this towers of Hanoi problem. And summary of this today's session is that in this particular CDT, we discussed about third important application of recursion is solving of tower of Hanoi problem. So this problem can be solved in such a way that our aim is to move disk n from the source to the destination and then put all other n minus 1 disks onto it. So we can imagine to apply the same recursive way for all given set of disks. So the tower of Hanoi puzzle with n disks can be solved in minimum 2 power n minus 1 steps. And these are the three important steps which we are going to write as an algorithmic steps for solving of this particular problem. First, we have to move n minus 1 disks from source to auxiliary, and then move nth disk from source to destination, and then move n minus 1 disks from auxiliary to destination. Got this point? So this is what you have to understand from where to where we are moving. So first n minus 1 disk from source to auxiliary, and then nth disk source to destination, and n minus 1 disks from auxiliary to destination. These are what algorithmic steps for solving of this problem. Fine. So we also wrote this function, recursive function for solving this problem in C. Okay. So thank you. And this is about the lecture level practice problem. So write the C code to reverse the given string using stack. So these are the further readings on this particular topic. Okay. So thank you one and all.